Hello friends, in this session we will go through the question paper solution of VTU June-July 2025 examination of the subject microcontrollers of the module 4. So that is question number 7a. Explain the following. Under that sub questions, first one interrupt, second one interrupt service routine, third one interrupt vector table. This is for 8 marks. So first we have to start with the interrupt. So here you have to represent the types of the interrupts that is available within the 8051 microcontroller. So the first statement, an interrupt is external or internal event that interrupts the microcontroller to inform it that a device needs a service. So this is the definition. Then totally 6 interrupts are available in 8051. So that's what the naming, and list all of them. First one is the reset, that is power on reset, and then two timer interrupts, timer 0 and timer 1, two hardware interrupts, that is external interrupt with respect to pin 3.2 and pin 3.3. We call them as INT 0 and INT 1. One serial interrupt is available which covers both for receiving as well as the transfer operation. So this is all about the first sub question, that is interrupt. Getting into the second part, that is interrupt service routine. Basically, interrupt service routine is a small part of the program which is going to serve as what the interrupt caused and what has to be done. So that is what we call it as the interrupt service routine or the interrupt handler. So you have to provide a small example considering either the timer interrupt or the serial communication interrupt to illustrate this interrupt service routine. Consider a pseudocode, so that will be enough for this one. The last part is the interrupt vector table. So these are the interrupt vector table representation. So it is going to have a standard memory location representation within the RAM. It's a fixed location. So you have to write down this table for it. Question 7b. Write the instructions to first sub question. Enable the serial interrupt, timer 0 interrupt and external hardware interrupt. Second sub question. Disable the timer 0 interrupt. Third sub question. Disable all interrupts with a single instruction. Use bit manipulation instructions for all these cases. Now this is specification given. In order to work with all these sub questions, we must make use of only the bit manipulation instructions. And this is for total 6 marks. Now let us get into the solution of it. So we must first identify in which register we need to operate. So that is, in this case, it is the interrupt enable register. So write down the configuration of the interrupt enable register, all 8 bits, and then let us get into the solution of this one. Now, before getting to the solution, we are going to make a consideration that within this interrupt enable register, EA bit, that is the location 7, D7, the EA bit is set equal to 1. Then after, we are going to make a solution of these sub questions. First sub question, enable serial interrupt. So serial interrupt is available in the location D4. Therefore, set bit IE.4. Remember, all these are bit oriented or bit manipulation instructions. So set bit IE.4, it is going to enable the serial interrupt. Next one, timer 0 interrupt. So timer 0 is available in the location D1. Therefore, set bit IE.1. The third one, external hardware interrupt. So external hardware interrupt is available for us in the location D2. Therefore, so set bit IE.2. So this is with respect to the first sub question. Second sub question, disable the timer 0. So disable in the sense you must make that bit is equal to 0. So timer 0 available in the location D1. So clear that bit. So clear IE.1. Third sub question, disable all interrupts with a single instruction. See, enabling or disabling of all these depends on this one particular bit, that is EA. So that's what is being written here. A enable all must be set equal to 1 in order for operation of any of these bits further, or if it is being reset, then this complete register will be disabled. Therefore, disabling this bit, that is setting this bit equal to 0, will disable the complete interrupts. Therefore, single instruction clear IE.7, it disables all the interrupts. Now with respect to sub-question A, you can also make use of this particular instruction if you want to operate all these three interrupts together. But anyhow, this instruction does not comes under the bit manipulation instruction. So I am taken it separately for all these cases. Question 7C, explain the bit contents of IA register. This is for 6 marks. So IA stands for interrupt enable register. So this is for the configuration of the IA register. What each bit is going to perform, that you have to make a list of them, and it is being represented here. Question 8A, list the steps involved in executing interrupts in 8051 microcontroller. This is for 6 marks. Now, what happens at each stage of interrupt, that we have to make explanation over here. So upon the activation of the interrupt, the microcontroller goes through the following steps. The first one, it finishes the execution of the current instruction, saves the address of the next instruction, that is with respect to the program counter, onto the stack. Then it also saves the current status of all the interrupts internally. It jumps to the fixed location in the memory called the interrupt vector table that holds the address of the interrupt service routine. Then upon executing the RETI instruction, that is return from the interrupt instruction, the microcontroller returns to the place where it was interrupted. So that means from the stack, the old address will be loaded back to the program counter and the normal execution resumes. So if you want to elaborate this one, you can elaborate with 2 to 3 more points for this. Question 8b, assume xtal is equal to 11.0592 MHz. Use timer 0 to create a square wave. Write a assembly program to continuously gets a 8-bit data from P0 and sends it to the P1 while simultaneously creating square wave of 200 microsecond period on port 2.5. So this is for 8 marks. So here you have to make an observation. So in the program you have to address two concepts. First one is you need to have a data transmission, that means assembly level language to continuously gets 8-bit data from P0, receive the data onto the P0, same data will be sent onto the P1. So this is related to the serial communication part. The second part is generation of the square wave of 200 microsecond. So this is related to the timer concept. So both of these two has to be written in a same program. So we need to first identify how much is the delay required in order to create a square wave of 200 microsecond. So here you can observe a square wave, you can observe the total duration of one complete cycle is what 200 microsecond. With respect to half cycle, that is on time or the off time, both of them are equal in the square wave. So we are going to calculate the delay for either on time or the off time, that is equal to 100 microsecond. So the same delay for on time and off time we will keep repeating, so that contributes total cycle of 200 microseconds. Right? So now getting into the solution. So internal time calculation. So this is with respect to the given frequency. So it is going to generate 1.085 to 10 to the power of minus 6 internal time. So consider timer 0 in mode 2 because it is clearly mentioned use timer 0 to create the sine wave. So we are making use of the timer 0 in mode 2 we are using. So it is a auto reload option. So th naught we are going to load the value. So that's why it is written th naught. So how much time we do require? So that is being written over here. Then the total count value required is being represented over here. So 92 is the count value that needs to be loaded to the th naught in order to generate a delay of 100 microseconds. Right? So now getting into the program. So this was the small part of the program, the initialization. Then bypass the interrupt vector table org000ph. So timer 0 interrupt vector table. There we are complementing port 2.5. So this is the port where we are going to generate the square waveform. So once we are going to keep that in the on cycle, then we need to switch over to the off cycle, then perform the complementing operation return from the interrupt. So this is what the small interrupt service routine being written here. So previously we were discussing about the interrupt service routine concept. For that question, you can have this part of the program as a solution there also. Now getting into the remaining part of the program. So here is the main part of the program we are going to have. So we have to set the T-mod register and then we need to set the P0 and then move th comma 092. So this what again we are setting the operational requirements over here. Then interrupt enable register. So enable timer 0 interrupt we are making use of. So that's why this was the specific value 82H and then start the timer. So since we are going to make use of the interrupt directly, whenever the interrupt occurs, it will move out to the interrupt service routine and then it will run that and it will come back over here. Right? So till then it will be sending the data through the port is being represented over here. Move a comma p0 data received from the port to the accumulator. Then from the accumulator it is being sent to the port p1. So again short jump back, it will come back here and it will keep performing the movement of the data from p0 to the p1. So with respect to the timer, whenever the interrupt occurs, it will move out to that interrupt service routine, performs the complement operation. Again, it will come back and it will keep running that square wave representation over here. So this is about the program we are having. Now 8C, write the interrupt priority upon reset in 8051. Also explain how the priority of the interrupts can be set upon IP register. So this is for 6 months. So two concepts here. So power on reset, what will be the default priorities that we need to represent. Second thing, how to override that default priority, that we have to represent that using the IP register. So these two concepts has to be discussed here. So the first one is by default power on reset. So after power on reset, this is what the priority we are going to have. So this is the highest priority. External interrupt 0, that is INT 0, will get the highest priority. Then to the timer interrupt 0, then external interrupt 1, timer interrupt 1, and last is the serial communication. So this is the default power on reset we are going to have. Right? So if you want, you can have few theory words regarding this one. Now getting into the IP register concept. So this what the IP register we are having. First you need to write down the IP register. So this is called the interrupt priority register. So as we keep changing this bit representation to 0 and 1, so we can keep changing the priority or we can keep overriding the default priority concept. Right? So that is being done over here. So we must understand what is the meaning of all these bits. So that is being represented over here. An example, so if the priority is set equal to 1, then assigns higher priority to that particular bit. If the bit is equal to 0, then it indicates the lower priority to that one or the default priority. Right? As an example, let us get into this one. So move IP comma hash 00000100B. So B indicates the binary. So this is what is being loaded to this one. So this configuration indicates at position 2 is being set equal to 1. All other bits are set equal to 0. Right? So that means IP.2, that is this particular interrupt at this location that belongs to the INT1 will get the highest priority of all the available interrupts. That is we are overriding the default priority concept over here by setting the bit 2, that is the INT1 over here. The same instruction can also be manipulated or written with a bit oriented instruction as set bit IP.2. So both of these two stands with the same. Whenever we are using the bit manipulation instruction, so initially we have to make an assumption that all bits are set equal to 0, and then we are making change to that one particular bit. That we have to have the consideration. So like this, you can have any other examples over here in order to represent the overriding of the priority. So keep in mind that, so don't work with bit 5. So bit 5 belongs to the timer 2, which is not a part of 8051. Therefore, do not make any operations on the bit 5. Thanks for watching.